Okay, so we're going to be doing sound waves today. A lot of you guys came to me and told me that taking notes off the video was really helpful. So we're going to try it this way. Don't worry, when we're finished, we will go over them together as a class so that we understand them and can ask questions. This is going to be page 20 of your notes. Please write page 20 at the top. Make sure it goes behind page 19. That's the proper place for it. Some of you guys are keeping a really beautiful notebook and you're doing a great job with it. Some folks are just putting these papers wherever they want to put them, and they lost a lot of points. So make sure that you're keeping your notebook up and that everything goes where it belongs. So sound waves. First, let's take a look at them. Sound waves are longitudinal waves. What you're seeing here is a picture of air molecules. Now, where do you think these sound waves are traveling? Are they traveling in one direction or are they traveling in every direction? Well, it seems to me that they're traveling in every direction. That makes a lot of sense. Let's say that the sound is happening right in the center of that circle. If that's where the sound starts, like right here, then that sound travels outwards in all directions. You don't have to be standing in front of it. You can be standing behind it. You can be standing to the left or to the right. And it goes in every direction. You can hear that sound. Now, this makes a lot more sense if we take a look at a moving version of this. So over here on the left, you see a sound wave being created. Now, a longitudinal wave has two things. It has compressions and rarefactions, and you can watch them traveling outward. But anyways, back to our, whoops, that's not the tab I wanted. Back to our slideshow itself. So here's what's going to happen when you create a sound. Step one, something will create a vibration. It can be my hands. It can be something in my throat making me speak. It can be a musical instrument. It can be anything creating a vibration. It could be an earthquake. If that vibration is passed along by particles bouncing into each other, then your sound wave is going to start to move. So the second part, vibrating particles will bounce off of each other, and then they'll bounce into the next one, and then they'll bounce into the next one, and that creates a longitudinal wave. The wave carries energy through those vibrating particles. We call that sound energy. And of course, for us to hear it, the sound waves have to make it to our ear. Now make sure you do have this written down. If you need to pause so you can write them down, please pause this video so you can copy this down. Go ahead. All right, so as a quick review of longitudinal waves, I want you to label the different parts that you see here. You might want to pause this video so that you can label whatever you find here: compression, rarefaction, wavelength, amplitude. If you need a reminder, it's on page 16 of your notes. You're welcome to go back and check. Go ahead and pause the video now and do a little labeling. Okie dokie, hopefully you did pause it and you're not just letting this play through. If you are pausing it and filling this out, if you make any mistakes, that's okay. Fix them as we go. So your compression are the areas that are a high density. And just by looking at this one, I can see that this one has several compressions. One right there. It's got one right there. It's got one right there. It also has rarefactions. Rarefactions are right here, or right here. Now, if I was measuring the wavelength, I would measure from one compression to the next. And amplitude's a little funny. To measure amplitude, I'd have to measure the density of the compression, or how strong the compression is. Which leads to a bit of a problem. Measuring longitudinal waves is hard. Now, seriously, think about it. If I wanted to measure this wave, where is the point where I would start measuring? I know wavelength is from like one compression to the next, but where exactly do I start measuring? Like right in the middle? Well, what part is right in the middle? And if I wanted to measure its amplitude, I just eyeball it, but I can't really measure its density. We've got a problem here. First, I don't know what part of the compression I should measure. Second, I have to remember how to find the density of the compression. Then can I do that quickly, or does that take time to sit down and calculate density? So some of these can make measuring a longitudinal wave's amplitude and wavelength really difficult. Which one do you think is the worst? Give some feedback, pause the video, and write down what you think is the hardest part about measuring a longitudinal wave. All right, so scientists understand this. Measuring the longitudinal wave is hard, so they do what anyone would do. They cheat. They totally cheat. They noticed something about longitudinal and transverse waves after studying thousands, if not millions, of diagrams. They saw that things like electromagnetic waves, which are transverse waves, things like radio or microwave or infrared, they have some stuff in common with things like sound waves. And when you put them together, you notice that the compression is a little bit like a crest. The rarefaction is a little bit like a trough. And if you take a look at a sound wave and you measure like its compression's pressure or its strength, if you turn that into a graph, this part has high density, high pressure. This part has low density, low pressure. You can turn a longitudinal wave into a transverse wave. And that's what we do when we study sound. Sure, sound is a longitudinal wave, but it makes it so much easier to show it like it's a transverse wave. You turn the compression into crests, you turn the rarefactions into troughs, and even though sound is longitudinal, you got something that's easier to study. So at this time, go ahead and hit pause. This is pretty much the end of the video. You can hit stop for all I care. And make sure that you filled out the last thing at the bottom. If you have done what you're supposed to do, the front part of page 20 should be completely finished. And there is no backside to this one, so you are done with page 20. If you have any questions, you can go ahead and ask them. We're going to go over this together. If you've got nothing else to work on, you can go to Study Island. You can take a look at helpful links for sound. You can go to BrainPop and look up things on sound waves. I think your first stop should probably be doing your homework, though, if you don't have that done. All right, guys. We'll talk in a few minutes about what this really means.